What up, everybody? Back at you with another parallel VIRP chart. And we're given some pretty spotty numbers this time. So is this going to be enough to fill out the VIRP chart? Unfortunately, the answer is yes. So if you have a problem of your own like this, we can't really do anything vertically. Like with these columns, we don't know any of the voltages. Current, we have two of them, but we don't have the third. And then resistance, we don't know the third one either. The only thing we have to go with is we have two numbers in the same row. And if you have two numbers in the same row, you can always find a third. So let's look at what we can do with these. We have an I and an R, right? And so that would allow us to find the V with this equation. Ohm's law, V equals I times R, current times resistance. You multiply those, you get 40. All right, so good news. The voltage drop across each resistor in a parallel circuit is equal to the voltage of the battery, which means we could put 40 in all these columns for the remaining two resistors and also for the battery itself, the total voltage. Now, what can we do? Well, we have now two values in this row. So let's see if we can find something with V and R. All right, current, according to Ohm's law, is equal to V divided by R, voltage divided by resistance. So let's put those numbers in. You get 4. Right. Next, we have all three current values for the resistors now. So let's just add those together, because in parallel, you add them together to get the total current. The current that's in the main branch of the circuit is 20 plus 4 plus 10, which is 34. Now we have some rows with two values in them, V and I. We can find R by taking V divided by I, right, giving us those numbers there. Okay, now we just need to find power. Power is equal to I times V, current times voltage. So we're just going to multiply the V and I's and get those numbers right there. All right, so we solved it. Let's look if it's reasonable. We have all the voltages are the same, which should be the case in a parallel circuit. We have the current values all adding up to the total, which should happen in a parallel circuit. The total resistance should be less than the lowest resistor, and we see that it is. Right, and the total power should all add up to, the power of each light bulb should all add up to the total. And so 800 plus 160 is 960, plus 400 is 1360. So we have solved it. It looks good. Feel free to click on one of these other VIRP chart videos if you need more help on this subject, and I'll see you in another video.